Okay, in this video we want to look at the powers of I. Remember, I is that imaginary number that's the square root of -1. Before we look at powers of I, consider two unique numbers in our real number system. First is the number 1. No matter what power you raise 1 to, you're always going to get 1. 1 to the 0 is 1, 1 to the 1 is 1, 1 squared is 1, 1 to the third is 1, and so on and so on and so on. And the other number that's kind of unique is -1. See, although -1 isn't always the same thing, you'll notice that the powers of -1 alternate. -1 to the 0 is anything to the 0 is 1, then -1, then 1, and then -1. And it just continues repeating that pattern over and over every 2 times. Well, it turns out the number I, very much like 1, and -1 has this behavior where it repeats. And it's actually going to repeat every 4 times, as we're going to see. So now consider I, which is again defined to be the square root of -1. As an immediate result, since I is the square root of -1, we have I squared equal to -1. So now we can kind of summarize here. I to the 0, as with anything to the 0, is 1. I to the first, anything to the first power is just itself. And as we've just noted, I squared is -1. Now consider I to the third power. We can write that as I squared using properties of exponents times I. I squared is a -1. I is just I, so I to the third power becomes -I. So far we have 1I, -1, -I. Now if we go to the next power, I to the fourth, well, we could write I to the fourth as I squared times I squared. I squared is -1, but so was I squared. And so -1 times -1 is 1, and we're right back to the same thing that we just got a moment ago. Oops. Right, we're back to that same thing that we just got a moment ago. We're back to 1. And if we continue looking at powers of I, you can see that that happens again. The next one would be I to the fifth. I to the fifth we could write as I to the fourth. I choose I to the fourth because that's 1 times I. And so we're back again to just I, the same thing that we got there. So you can kind of see how this pattern is going to keep repeating. I to the sixth will be -I. I to the third, or sorry, I to the sixth will be -1. I to the seventh will be -I. I to the eighth would take us all the way back around to 1. So those are our powers of I. So you kind of notice here that it repeats every 4 times. And we can use this now to help us find powers of I for bigger things. Just like we could figure out 1 to any power and -1 to any power. We can do the same thing over here. So as an example, consider I to the 10th. And the key is how we break it up. We actually break it up into an I to the 8th, which is actually going to be an I to the 4th and an I to the 4th, so that's a 1 times a 1. So I to the 8th is just 1. And then I to the 2nd is -1. And so I to the 10th can be written as -1. As a second example, consider I to the 23rd power. So this time we're going to break it up, and we're going to break it up using the same kind of idea because it repeats every 4 times. We're going to find a power of I that's a multiple of 4. So in other words, we use I to the 20th. And then 3 left over. I to the 20th will be 1. I to the third, going back to that list of powers over there that we just wrote down, is -I. So the whole thing is just -I. And again, we're just going back to those powers that we have listed over there. for 0, 1, 2, and 3. So now one final example, we have I to the 45th. Instead of breaking this up into powers, another way to do this is to just do your basic long division and say, well, 4 goes into 45 11 times with 1 left over. The remainder is the power of I that I to the 45th is equal to. So I to the 45th is equal to I to the 1st, which is equal to I. So hopefully this helps you as you're looking at these powers of I. Gives you a little bit of a better understanding how they kind of repeat, just like the powers of 1 and the powers of -1. Just keep repeating.